So really you don't have to guess very hard what's on the bench today, because it is a digital microscope, and in this case it's the Andonstar AD409. Now the AD409 has actually been out for a few years now. If you take a look on the interweb and on YouTube, you will find lots of reviews for these, and I'll actually put a link in the show notes. Now I'm sure you can purchase these through companies like AliExpress and Banggood, but I actually went ahead and I purchased this one from Amazon. And for those playing along at home, I did pay for it myself, and it was relatively expensive, because it was actually around £350. So unfortunately not exactly the kind of money that you'll find down the back of the settee. But for a microscope it's still at the relatively cheap end. So let's go ahead and find out what we get for our 350 British pounds. Okay, so it looks like on top of the box we've got an operator's manual, 24 pages long. We'll take a close look at that a little bit later. Okay, so there's the money shot. So it looks as though this microscope does actually come with quite a large screen, so we'll get that out. Now I'm afraid I've got to admit, when it comes to things like cameras and microscopes, I really don't know very much about them. About as much as I know is roughly the direction that you need to point them in, and I'm afraid that's my lot technically, so we'll just have to do the best we can with this. So as you can see, we have got quite a large screen here. Not exactly sure what size it is. I think it might be about 10 inches. You probably want to know, don't you? Let's get a ruler. Well, if I was at school now, I would have just got a right slap from my English teacher, because of course this is a rule, it's not a ruler. Rulers rule countries, whereas a rule, you used to measure things. So yes, I would have definitely got a slap for that. Now I think you actually measure monitors cross-cornered for some pointless reason. So it looks as though across corners, yes, it does look like it's about 10 inches. Let's go the other way, about 9 inches. So diagonally, it's 10 inches from corner to corner. All the way across it's about 9 inches. Let's see how high it is. It's about 5 inches high. Now of course I should give you that in metric, shouldn't I? So it's about 26 centimetres across corners, 22 centimetres wide, and it's about 13 centimetres high. Now I'm not certain, but I think there might be a screen protector on here. I'm sure there will be. I think we might actually leave it on, because I am quite accident prone, so that screen protector, it might as well stay on for now. I can see on the front of the screen we've got various push buttons. It looks like an on and off control and maybe some zoom controls. We've got a little window on here, so I'm guessing this is maybe for an infrared remote control. Let's just turn it over and have a look at the other side. And I guess that's really the business end, because this thing here pointing down at kind of a jaunty angle, that's actually the camera system with its lenses. So yeah, that's kind of the important part, isn't it? So we've got a power adapter which is actually set up for the UK plugs here, 3 pin. And it looks as though that's got a USB output on it. Of course I grew up with linear power supplies and, you know, great big transformers in things, so I'm still gobsmacked about how small some of these little switch mode power supplies actually are now. Quite incredible. Okay, so we've got a piece of metalwork here, some ironmongery. Not sure if we can call it ironmongery, because it is actually made out of aluminium, some kind of alloy. So I'm guessing that this is, well, as you find on lots of microscopes, this is some way of actually adjusting the height of the thing. So we've got a little rack and pinion on here, and I can notice that if I turn it we can actually probably make the microscope go up and down, and we've got a mounting at the far end here. Oh, there's the aforementioned remote control unit, so again we'll take a look at that later. Got some metal clips of some description. Let's take this out and have a closer look. Well, I think to start with I'm just going to uncover the base unit here, because I'm sure that this piece of white material is upsetting the camera. So hopefully the contrast levels will now return to normal. So we can see here we've got a base unit which again feels like it's made out of aluminium alloy, not incredibly heavy, but still quite substantial. And we can also see that we've got some little LED spotlights. Well, I say little, they're not particularly little, and they're on these flexible gooseneck stalks, and they actually seem to stay where you put them, so that's a first, isn't it? I'm going to point them up like that. Looks like you've got some kind of alien looking at you that way. So we've got a cable, not sure what type it is, let's take a look. Okay, so it looks like it's HDMI at one end. Well, is that HDMI as well? I think those are HDMI cables. Don't know what they're for. We'll put them on one side. Plastic bag. Okay, we've got some hardware in the form of Allen screws, and oh, it comes with a little Allen wrench. In fact, let's tip the little baggie out and have a look. Nearly lost the spring there. So because I have watched some review videos, I know what most of these parts are. So I think one thing that you can do is, quite often when you're actually looking at things on proper microscopes, quite often you might have a slide or something and you want to mount that slide, stop it sliding off the table of the microscope. So they come with these little clips here, but for doing circuit board work like I do, these are just actually going to get in the way, so we're not going to go ahead and install them, so I'll put them on one side. Here's our Allen screw. Again, I think these springs here that we get a couple of, I think they're to do with those little clips that we won't be using, so we'll put them on one side as well, as are these two screws. So I think these are actually the two droids we're looking for, and the Allen key, because I believe that we actually need these to actually fix this this upright stand. We need to fix it onto the base, so let's do that. And it looks like the upstand itself is actually tapped, so it should accept the screws that we've got. So let's put one of the screws through here. Now, as you can see, this actually does require very little assembly. I'm going to make a muck of this, aren't I? Trying to talk on camera and line screws up. So the microscope itself comes pretty much fully assembled, so all we've got to do is put it onto its stand like this, and then just, I think, connect up a few wires, and in theory we should be ready to go to the party at that stage. Okay, so that's one of the screws on. Let's see if we can get the other one in now. Just notice the base itself does come with these quite large rubber feet, so they maybe just help damp a little bit of vibration. And I have also just noticed this piece of moulded black plastic. Now if we turn this over, I can actually see there's a little connector on here, so I'm just going to make a guess that we actually plug in something here to power up these two lights. So yeah, that must be some form of power adapter that plugs into there. So this has got some controls on, which is showing a lamp. So again, this looks as though we can maybe control these lights on the front of the microscope. So I'm guessing that, yeah, one of these connectors must plug into this little box at the back here. So yeah, let's go ahead and plug that in. I've got to admit, I am getting slightly annoyed at just the amount of wires and cables that this thing comes with. I'm sure it's not really necessary. I don't know why they didn't embed the actual controls for the lighting into the main unit. This just seems like a little bit of a faff, actually. But that doesn't look right. Have I got that the wrong way up? Yeah, I have. Should have read the manual, shouldn't I? So that goes that way around. I was just testing you there. I'll edit that out. Nobody will see it. Well, I am admitting defeat by taking a glance at the manual. Now, I have just noticed that in theory this little microscope comes with a little UV filter which screws on the camera, but I haven't actually seen that in the pack of bits we've got. So is it actually already installed? I'm just going to take this off and have a quick look. Oh yeah, I think it is already installed on the end there. Oh yeah, that does screw off. So if you're looking for the little UV camera protector, lens protector, it's actually already installed. So in theory all we have to do is turn the unit round, and we actually just have to secure these two little thumb wheels here. So I'm just going to level it up, I'm going to screw them in, and the other one. Notice that the ends of the screws do have some little pieces of soft plastic on the end of them, so I guess that the idea is they don't crush or damage the actual lens tube here. Okay, I've just put them finger tight. So I've just noticed that we have got some connectors and other doobies at the top of here, so it looks like we've got that miniature HDMI connector there. Then we've got, I'm going to call it a USB-C connector, but I'm not sure. And then I think we've got a slot there, so again I'm taking a guess that that must be for a micro SD card. And then we've got another connector here, which I'm not sure what that's for. And again, having to resort to reading the manual, it looks like the manufacturers also don't know what this connector's for because they don't mention it. Looks like this USB connector must plug into here, because it's the only place that it'll actually fit. Now we have still got the HDMI cable. I think this may be used for an external monitor or something like that. So again, I don't think we're going to be using that, so again we'll put it on one side. Now just an observation, there does seem to be a little bit of a lack of cable management going on. I'm not sure if they could have done anything better. Not sure, but I think these cables flopping around could possibly get quite annoying after a while. Let's turn it round and plug it in. So both the microscope itself and the two lights are powered from this USB cable, and the unit comes with a 230 to 5 volt adapter. And just looking at that, it's actually 2 amps. Again, it always amazes me how small these little power adapters are now. So what we'll do is we'll go ahead and plug it in. Now I've also got one of these little inline current and voltage monitors, because we will actually see how much power the microscope actually uses, because there might be times when you maybe want to plug this into a laptop rather than have a power supply. You might be out in the field or something like that. So I'm just wondering how much current this would actually take from a laptop or a power bank. So maybe we can find that out. So we'll plug that in. We'll plug my power adapter in. Okay, and it's just showing me at the moment that the output is 5 volts, and of course we're not drawing any current yet because we're not plugged in. Oh, and as soon as I did plug in, I've just noticed that both the lights come on. In fact, both the lights have come on. I hope you can see that. The microscope's actually powered up. And with the microscope and lighting powered up, I can see that we've got a current there of about 1.1 amp. So let's put a circuit board under our microscope and actually take a closer look at it. Wow, well the magnification does actually seem pretty high, and first impressions are that the actual screen and the camera system, it's absolutely beautifully crisp and clear. So let's just see if we can work out what the magnification actually is. So I'm going to put a rule under the microscope. Let's see how much we can see. So I've got the microscope set at the moment pretty much on its high limit, so we can't actually go any higher. So this is the widest thing that we can actually fit under it. So just counting that, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's we're looking at 12 millimeters filling the screen there. So let's just measure that again. So we've got 12 millimeters, and that's about 220 millimeters. So let's get a calculator. We'll just do 220 millimeters divided by 12, and that gives us a magnification there of about 18.3 to be precise. Now we should be able to increase that magnification if we actually lower the microscope down on its stand. So let's have a go at that. Now unfortunately it does appear that we can't actually get much lower because unfortunately it's out of focus. So let me find the point where it will come back into focus. Okay, so I think we're about there. Let me just realign my rule. So now we've got 1, 2, 3, 4. I think it's probably just about 5. Yeah, just about. So 5 millimeters there when we zoomed right in. So let's just measure that again. Of course that's going to be 22 the same, so let's do the math again. So 220 divided by 5. Okay, so now we've got a zoom level of 44. Now apart from the optical magnification that the microscope offers, it does also have digital magnification or digital zoom. So I think if we press these buttons here, I've got to get the right one, I think we should be able to zoom in even closer, which we can do. So let's increase the digital zoom to its maximum. I think that's where we are. Now even though we've increased the digital zoom to its maximum, I can see there's just a little bit of noise on there, but it's still pretty good actually. That's still pretty clear. Let me see if I can just realign the rule slightly. I think we're showing about 2.5mm there, so let's take our calculator again and do 220 divided by 2.5, and that gives a number of 88. So that appears to be the maximum zoom level, 88 times magnification. Well, as you've just seen, I've been using my microscope just to do some inspection on some boards that we had lying around, and a couple of things have become apparent. Firstly, my surface mount soldering isn't particularly good, and that shouldn't come as any great surprise because it isn't something I do very often. The picture quality itself is absolutely excellent. It's crystal clear and pin sharp. And whilst I move the board around, there's absolutely no lag. And I have found that to be a problem when using some other USB based microscopes. And I think for inspection of circuit boards, this microscope is pretty much unbeatable. It works very well. But unfortunately, I don't think this particular microscope would work so well for those of you that are planning to do some surface mount soldering. And one of the problems that I've spotted is a relatively narrow field of view. And for example, if I wanted to solder the pins on this IC here, the problem is I can't actually get all the IC in shot. The actual field of view, it's just not wide enough. And again, just an example of that, I can actually only get about half the pins on this particular IC in shot. And I don't think you would actually want to have two goes at this. You would just actually want to run from one side or the other with your soldering iron. And the problem I've got here is, unfortunately, we can't actually lift the microscope any higher because it's actually right at the top of the stand here. So unfortunately, this microscope is really restricted by the length of this stand here. And actually the focal length isn't quite right in that we can actually focus this. We could actually lift this off. In fact, let me just demonstrate that. If I actually lift this camera right the way up here and reattach it. Now, you shouldn't really mount it like this because I think it probably would put quite a bit of stress on the tube here, on this lens tube, and I don't think that's a good idea. But if we do lift the camera up like this, we should have to be able to see a lot more. And as you can see, with the microscope now in this raised position, we can actually now fully see all the pins on this IC, so we could actually solder them without any problem, but we certainly can't solder them when the microscope is actually set up correctly. So Andonstar, really, I think they've really made a really big boob by simply not making the length of this arm long enough, this support column. And to be quite honest, I think that's pretty inexcusable because the actual focal length isn't really correct for this microscope. As you can see, it will actually focus right up here now, and when we've got it lifted we can actually even go all the way down and we can achieve a really good range of focus here. But when we have it set in its normal position, let me put it back. And as you can see, now I've actually dropped the microscope down, and in fact it's nowhere near as low as it could go. In fact, it's still relatively at the top of its stand. I can't focus it. So as the microscope is delivered from the factory, you've actually only got a very small focal range. It's actually limited to about 40 or 50 mil of the top end of this column here, which is not particularly usable. Another problem that I foresee is the actual working height here between the actual PCB board and the underside of the microscope lens. With the microscope raised up to the top of its column, the actual working distance between the underside of the lens here and the PCB board, it's not particularly great. And just taking a ruler and doing a quick measurement, I can see that it's approximately 70 mil. But having said that, I don't actually think I'd have much problems getting my soldering iron in. But if you've actually done any surface mount soldering, you can see it's quite a dirty process in that you tend to use a lot of flux, and it kind of splits and splatters and it smokes a lot. And I think it wouldn't take very long to actually get our lens of our microscope here pretty contaminated with the smoke and fumes coming off the soldering iron. The surface of our microscope platen is a textured paint, and it's actually very slippy. Now I actually think that's quite good from an inspection point of view because it means you can move the board around without it actually dragging on anything. But I think that could be a problem if you were trying to solder, because I think you would have a habit of accidentally just knocking the board around. And for that reason, a lot of people do choose to use these little circuit board holders, which really are quite handy. I think a lot of people who do things like mobile phone repair actually use these. Let's go ahead and actually put this little board in. Now this particular circuit board holder does have these little rubber pads on it, and it's quite grippy, so once we actually put this board into here it really is a prisoner. But unfortunately that's also further reduced our working height between the circuit board here and the actual underside of the microscope. So I'm just going to apply a few milli-Rothmans of flux to our IC here. And of course far too much is just enough in this case. And although this is already soldered, we're going to give it a go. A nice feature of our screen here is the way that we can actually tilt things, and this makes it particularly good for trying to line it up with the camera so that you can see what I'm doing. But one problem that I have noticed is actually the actual camera must be mounted in the head of the instrument here, in the head of the screen, because if we actually turn the screen, hopefully you'll be able to see, it does actually twist the view. Let me just see if I can turn it around. Okay, so you can actually see that our IC now is at 45 degrees. I actually think that's a bit of a problem. I don't think it should do that. I think you should be able to tilt the screen to suit any viewing angle you want, and I think the camera should stay put. So again, I think that is another problem with this Andonstar. I don't think that's a great idea personally. So of course there's no problem with the up and down bit, but tilting, yeah, the camera obviously twists along with the head unit here with the screen. Now of course we do actually have to take into account my very limited experience of surface mount technology, but I think that it isn't the ideal tool for soldering. And I think another problem that I've kind of found is that the actual throat depth here, the actual gap between the circuit board itself, the PCB, and the back of the upstand here, again it makes it quite restrictive for moving larger boards around. You wouldn't really be able to do it for a larger PCB. Certainly some of the PCBs that I work on, you wouldn't actually be able to get some of the ICs on here because there just isn't the depth here to get to the middle of the board, because the boards are just too wide. So again, I think that is another limitation. But when you have finished your soldering, it comes time to actually do some inspection. I think this microscope, again, it is the perfect tool as an inspection microscope. I have no complaints with that. In fact, we've just spotted a really horrible joint here, haven't we? That's a bit nasty. Let's see if we can just go in and touch that up. Probably make it worse. That looks okay to me. Now, just for comparison, I wanted to try my Amscope. And as you can see, this is what I would call a traditional microscope, and it's a binocular microscope in that it's got two eyepieces. And the important thing about a stereoscopic microscope like this is you actually have depth perception because you're using both eyes. Whereas the actual Andonstar, effectively, it's only got one camera, so it's got one eye, but you can actually have two eyes. You can actually judge depth. Now, when you're working with tools or a soldering iron on your circuit board here, of course, it's really important to be able to judge the height of your tools and the components when you're placing them. Now, I actually thought that the M-scope here would actually win hands down over the Andonstar because the stereoscopic vision here gives us much greater depth perception. But having tried the Andonstar, I've got to admit the difference wasn't quite as big as I actually thought, and I think that if you were using this kind of monocular style microscope, I think that you probably would get used to it relatively quickly. However, I actually still think that my AM scope, if I was to do surface mount work, I would choose this over the Andonstar. For quite a few reasons. I mean, one, because I said that the Andonstar doesn't have any lag. Well, it really doesn't, but of course, with a purely optical system, well, the update rate is the speed of light, so we definitely don't have any lag. The kind of colour rendering is better because it's purely optical, and probably the big thing is, look at this working depth here. I mean, it's absolutely huge. So it's actually about 23 centimetres as opposed to about 7 centimetres for the Andonstar. So for example, we can get the soldering iron here and it can be fuming away. We can get lots of tools and tweezers and we can be placing things, and we're nowhere near this lens because it's, you know, it's all the way up here where we are relatively close to the one on the Andonstar. And I actually think that, yeah, I just find that the fact that this is purely an optical system, well, the picture is perfect. The Andonstar is very good, but the optical microscope is perfect. Well, having just said how good the optical microscope is, it does have some downsides. Now, one of those downsides is I've actually got to get my head at the right height, and I've actually got to peer into the eyepieces here, so my back is kind of bending. It's not super comfortable. I'm sure I could get more comfortable if I spent more time adjusting my seat, but it's not super comfortable. The other thing is, when I'm actually soldering, if you actually look where my face is, it's almost pretty much in line with all the fumes and soldering nastiness that's going to be coming up. Now, of course, in a perfect world, I'd have a fume extractor, but for now, I don't. So you're more likely to be breathing in those fumes, and it's just a less comfortable experience. Again, I can already feel that my neck's aching slightly, and I've only been using this thing for 30 seconds. But in terms of picture quality and stuff like that, yeah, the binocular microscope does win. But again, coming back to using the Andonstar for inspection, I think the Andonstar is a winner over this microscope. So I think it really depends what sort of job you're going to be doing. Our Andonstar has quite a few other features which I think make it quite useful for filming and the kind of things that I do, because I want to show you things. So one of the things we can do is we can insert an SD card into it, and then we can record things onto this. Now, one thing I've immediately noticed is that the actual placement of the actual SD card receptacle here is actually quite poor, in that it's actually very close to the back of the unit, and I don't think my hands are particularly big, but it seems almost impossible to actually get this little micro SD card into here. It's not very easy to do. In fact, have I got that the right way around? Yeah, I'm not even sure I have. Let me try turning it around. Does it go better the other way? Okay, it does, but as you can see, that really was a little bit of a faff. It really doesn't want to be there. It should have been on the underside or the top of the instrument. That's a bit of a pain. Before we can record on the SD card, we need to format it first, so let's do that. We do that using these menus. I've got to admit, I haven't found the menus to be super intuitive, but we'll give it our best endeavour. So I think we need to scroll down here. I'm going to go to Format, and then I'm guessing it's OK. Scroll down, OK again. Please wait. I assume it's now done that. Did something a little bit funny there. It seemed to reduce the width of the screen, but it has come back again. So now we can either choose to take still pictures, or we can actually take a video recording. Now this I didn't find very intuitive, because we've got an OK button here. We've also got a picture of a camera. So I think the camera picture, maybe that takes stills, so we'll try that. So has that taken a still picture? I think it might have done. So if I press it again, will it take another picture? Now, as well as taking still pictures, in theory we can also record video, so let's have a go at that. I think you have to press the OK button, so let's try that. Okay, and I can notice here at the top of the screen we've got a little count up clock, so this must be how many seconds and in fact minutes of video that we're recording. So what we'll do is we'll move the board around, and then we'll take the SD card out, we'll see if we can download and have a look at them files. And maybe you'll be able to see if there's any difference between the actual recorded video that I'm using through my camera here, just looking at the screen, and maybe having a look at the actual information that's being recorded directly to the SD card. Maybe there'll be a difference, I'm not sure. So I'm going to switch the unit off now. Okay, goodbye. And in theory we can now remove the SD card and we'll play it back on another computer. Yeah, that is painful, that. I can see that a couple of file directories have been created on our SD card. So we've got one called Movie, another one called Photo, so I guess that's quite self-explanatory. Let's have a look in Photos, and let's just view that, extra large. Okay, so we can see we've got our still pictures here. Let's go and have a look at one. And those do look pretty good to me. Let's have a look in the movie directory at the video we created. Now, as well as using the SD card to record videos and pictures, the Microscope also has Wi-Fi connectivity, and I did actually go ahead and I set the Microscope up on my Wi-Fi network and I didn't have any problems to connect to it. The only problem is I believe that the Microscope only works with Andonstar's own software, and that software in many ways looks quite good in that you can do lots of video manipulation, you can take measurements, and you can also do various types of filtering and rendering on that video. But unfortunately, having downloaded the software from Andonstar, it doesn't actually work, or I couldn't actually get it to run. It seemed to be missing multiple DLLs. But in the end I did decide not to go hunting for all the missing DLL files, and I went ahead and I uninstalled the software, and I've also just disabled the Wi-Fi connection because, well, you never quite know what you're connecting into, do you? But using this menu we can go ahead and switch the Wi-Fi on and off. It's just a shame that it isn't simpler to connect to the device using Wi-Fi. I don't know why I have to use the Andonstar proprietary software, because I'm sure there should be some way of just connecting to this as a Wi-Fi camera, but if there is a way of doing that, I haven't found out how to do it. I've seen from watching other YouTube videos that it's possible to put grid lines up on the display, but unfortunately I haven't managed to get that to work. It doesn't seem to be able to turn them on and off, so I'm not exactly sure what's going on there. Also got date and time settings, which I've just gone ahead and reset. Language, of course it comes in all the usual languages. Frequency, that's set to 50 Hz, which I assume is good for the UK. You've already seen me formatting the SD card, and then finally we've got an option here to return everything to the default settings, which is useful if everything goes wrong. We do have some options here to actually change the screen resolution, although I'm not really sure what we would need to change them for, so I'm going to leave them set to the default. We've got a quality menu, and I think that might be something to do with the file size that it records, but again, not exactly sure because it isn't explained. We can change the sharpness of the picture. Again, I'm going to leave it at its default, which is normal. We've got white balance, which we've got options to change to daylight, cloudy, tungsten or fluorescent. I'm going to leave it at the auto setting. So we've got a colour menu here, let's take a look. And apparently we can change it from normal, which it is at the moment. We can have black and white, sepia or negative. I think what's probably most useful out of these is negative, because sometimes certain things within a picture will show up better as a negative rather than a positive image. Let's have a quick look at that. And as you can see, the tracks on the circuit board do actually show up particularly well with the negative view, as does the component ident labelling. Now, I have also noticed that on occasions when I've been switching through these menus, the Microscope itself has actually crashed, and sometimes when you return from them, the actual picture size here appears to be reduced, and sometimes it comes back and sometimes it doesn't. So I'm not sure what causes that, but generally to get the full frame back I find that I have to switch the Microscope on and off again. And now as you can see, the actual full frame has recovered. Now the Microscope does actually come with this remote control unit, which at first sight would seem to be superfluous, but there is actually some logic to it in that when you're actually trying to take still pictures and things like that, whenever you actually touch the Microscope like this, you'll find that you do actually make the image shake slightly, whereas if you actually operate the Microscope using the little remote control here, that avoids the shake. So let's have a look at that. Now, interestingly enough, we've all bought things from China for just a couple of pounds, and it's not unusual to find that those things will come with batteries. But interestingly, when you spend in excess of £350, you get a remote control and they don't have the batteries in it. So in terms of expenditure, it looks like a couple of batteries was just a bridge too far for Andonstar. And of course, when it comes to test equipment, we do tend to go that extra mile, and we're going to fit lithium batteries. The advantage of lithium batteries, of course, is that they never leak. So let's see what our remote control can do. So we'll start with the red button at the top here, which shows a camera on it. So I'm guessing that that's going to take stills, which apparently it does. We've got a menu button, which allows us quick access to the menus, and I'm sure we can then scroll up and down as we did previously, which we can. Press menu again and assume that's going to make us go back. We can control the zoom level because we've got a little up and down arrow with magnifying glasses on, so let's increase the digital zoom. And again, that does actually work quite nicely, and it is easier than pressing the up and down buttons on the actual front display of the camera. Also got a freeze frame button, which is useful, so we can freeze the frame. Let's do that. Has that frozen? I'm guessing it has. Can we move this now? Oh, that didn't work. Let's try that again. Freeze frame. Okay, there we go. Unfortunately, one thing it doesn't seem to provide an indication when the frame is being frozen. Does it unfreeze if you press it again? Yeah, it does. So you obviously press the button once to freeze the frame and once to unfreeze it. Let's try that again. Press the button once. Okay, there we go. It has frozen that time. And we can now examine the board, maybe compare it to what's on the screen. Put it back under. Let's unfreeze that. There we go. We've got the 50 and 60 Hz button. Let's see what that does. Well, it looks as though the 50 and 60 Hz button tries to turn on the Wi-Fi, which, well, not sure why it does that, but yeah, that's what it does. Let's see what the plus button does. Ah, okay, so the plus button this time, it's actually turned on the crosshairs. So we did mention that these crosshairs could be brought up, but actually for some reason when I use the menu on the microscope itself via these push buttons, I couldn't actually get the crosshairs to appear. Now things like these crosshairs where it's putting up various 4 quadrants of the display, these aren't very useful for me, but people like biologists use these because they like to do things like count the number of cells or bacteria in a certain quadrant. So again, maybe they're more of use for people who are into biology or something like that. So I think that the remote control unit does work relatively well, although quite a lot of the buttons on here seem to be a total mystery, and in fact I've got absolutely no idea what they do in truth, but keeps life interesting, doesn't it? I think another advantage of our Andonstar microscope here is the fact that it does have an all-in-one screen. It is relatively lightweight, it's very transportable, certainly compared to my big heavy metal stereoscopic microscope, so this could be quite useful if it was actually teamed up with something like a mobile power bank. And of course Andonstar actually do provide some software so that you can carry out the same measurement functions using an iPad or a phone, or you could record to the iPad or phone in just the same way that you can connect to a PC. But unfortunately it's also similar to the PC based software in that that doesn't work either. Certainly didn't have any problems establishing a connection between the iPad and the actual microscope, because we can tell we've got a connection. It shows up in the settings of the iPad, and also when we do have a connection it goes green, a little Wi-Fi symbol here. But unfortunately when you actually fire up the Andonstar software it just says please connect to Wi-Fi. Well, we are already connected but it still won't connect. So not only does the PC based measurement software not work properly, their mobile applications also don't work. So in the case of Andonstar, I'm sorry guys, double fail. Now it's quite possible that some of you that are watching the review of the AD409 aren't necessarily interested in electronics. Maybe you want to see some other uses of the microscope. So as you can see I've gone ahead and I've found some biological type samples. And what you can see under the microscope is a leaf, a mealworm and a selection of seeds that can be found in wild bird food. Pretty much filling the entire screen at the moment. I can see that we've got some type of seed. It seems to be a little bit furry at one end. Maybe it's starting to germinate, I'm really not sure. But underneath that seed you can see that we've got the leaf itself. Now one thing that is impressive about this microscope compared with many other microscopes I've used is that it's got a relatively good depth of field, in that you can actually see that the top of the seed is in focus, and actually the leaf that it's sat on is also in focus. In reality that distance is only 2 or maybe 3 millimeters. Let's see if we can focus in a little bit tighter on the leaf itself. No, that does actually look pretty good to me. And there we've got a mealworm. He's not going to win any beauty pageants, is he? But he probably thinks the same of me. Oh, he's got a friend with him, I can see. I've placed an M3 bolt under the microscope now, and although this bolt is actually brand new, you can actually see when you look under the microscope, the actual thread of this bolt is actually in fairly rough condition. I've got a very thin piece of metal under the microscope now, and previously I'd taken that piece of metal and I'd actually twisted it backwards and forwards until it broke in half. So what you're actually looking at now is the kind of microcrystalline structure from where the metal actually failed and tore out. Last week you'll remember that I tried and failed to repair a logic probe. Previously using a magnifying lens I did actually inspect the board quite carefully, but one thing that I didn't notice was this damage around the resistor pad. Now we can clearly see some signs of arcing, and the actual leg of the resistor where it goes through the pad, the solder has actually burnt itself away, creating a hole and a bit of a poor connection. Now we can also see signs of heat because when that solder was bubbling and getting hot, it obviously splutter coated one end of that resistor with bits of hot metal that were thrown off. So again, we don't exactly know what happened to this logic probe to cause the damage, but certainly it must have been something pretty catastrophic to actually cause this.
Mr. McGee, don't make me angry. You wouldn't like me when I'm angry.
If you take a look online, you'll find there's an awful lot of reviews on YouTube for this microscope, and most of those reviews will score the Andonstar AD409 very highly. Most of those reviews also have another thing in common, and that's that Andonstar actually gave them the microscopes to review. However, in my case, I did pay more than £350 for this microscope, although I do see now that at the time of publishing the video it has dropped to £300. But I'm afraid I have to say I'm somewhat less than impressed with this microscope. Every one of my product reviews has the possibility of scoring a 10 out of 10. So let's start off with the good stuff first. So the actual screen itself is absolutely beautiful, as is the resolution of the microscope and the colour rendering. There's also absolutely zero lag when you actually move the workpiece under the microscope. All that is absolutely perfect. So as a microscope, purely the optics here are first class. I have no problem with them. The actual lighting is also very good. It's dimmable, which I didn't show you earlier, but you can adjust the brightness, and these lights do stay where you put them, and they're also very well diffused, so you don't tend to get bright spots. That's great. But I'm afraid here comes the buts. And the biggest but for me is actually the fact that the focal range for the microscope really isn't correct. You can see that Andonstar produce a range of microscopes and they seem to use this same upstand on all of them. That's clearly a mistake because it's not high enough. The usable range of this microscope is something like the first 30mm. If you actually lower it more than that, you won't actually be able to focus it. So for example, you wouldn't be able to solder a large integrated circuit that had a number of pads because you can't actually get the whole of the circuit under the camera, you can't get it all in shot. So really what needs to happen with this stand here, it needs to be a lot higher. I'd actually say that it needs to be about twice the height. So if Andonstar was to increase the height of this column here, it would actually make absolutely a huge difference to the usability of this microscope. I think the cabling arrangement that they've got here is quite messy, and the fact that you can actually turn the microscope off in two places is a bit of a mistake because if you actually turn it off using the hand control here, it doesn't actually save any of the settings, so you actually need to switch it on and off using the on and off button here. But why actually give us one on this hand control? Again, I suspect it's because this hand controller is common to a number of different microscopes. I also think it's unnecessary. I'm sure they could have put the lighting control in here rather than giving me yet more wires that actually have a habit of just going underneath the microscope and getting in the way. Another thing that I found is the actual firmware that runs a microscope is absolutely full of bugs, and those bugs seem to show themselves most often when you're actually going in and adjusting some of the menu settings. Quite often it will exit the menu at the wrong time, and if it does exit it will actually lock the screen up, and then you've got to switch the power on and off to the microscope and reset it. Now that doesn't stop it being usable, but again it shows a lack of development, a lack of thought and a lack of testing, because those bugs really shouldn't be there. This remote control is actually close to useless. Sometimes it works, sometimes it doesn't. I found that I've actually got to hold it very close to the actual infrared sensor here, and it doesn't really provide very good feedback on screen when you actually press these buttons. The operating manual for the microscope is absolutely useless. There is 24 pages, but half of those pages are in Chinese, and the other half of the pages don't actually contain any useful information. It certainly doesn't describe what these buttons do on the handset. Now, we also found other software related bugs in that the PC software which is designed to be used with this microscope, it doesn't work properly and it won't connect using Wi-Fi. And as I said, they actually also produce a mobile app which will work on various tablets, including my iPhone. Unfortunately, that doesn't work either because, again, it has problems connecting on the Wi-Fi. Now, this microscope has actually been out 2 or 3 years and it's been reviewed by various people, some of which have actually reported these problems with the software. Now, for reasons unknown, Andonstar have chosen not to address any of those problems, which I think is a shame, because this could be an absolutely brilliant microscope, but there's just a total lack of care, detail and checking that's gone on in the development of this. I think this is really a case of Andonstar managing to grab defeat from the jaws of victory. So I actually think that, starting off with 10 out of 10, I'm going to immediately take off 3 points for the fact that the stand is utterly useless, and I'm going to take off another 3 points for the fact that the software which they supply with the microscope is also entirely useless. So in the case of our Andonstar AD409, I'm actually going to give it a 4 out of a possible 10, which is a great shame because the actual microscope itself could be very good. It's just been let down by Andonstar themselves. Now, a great tester is, would you pay for this with your own money? Well, I did pay for it with my own money. I have to say, I wouldn't pay for it again.
And you're no better, sitting there like dishcloths, ready to watch any rubbish these effeminate TV Johnnies care to dish up to you. Don't just sit there, do something. Move, get up, come here, switch off. Well done, weirdos.